Okay, this is Unit 5, Day 2. We're going to look at polynomials some more. Our learning targets, I can convert a polynomial from standard form to factored form, and from factored form to standard form. So go in both directions. And then I can identify zeros in the multiplicity. That's a new word. So that's like a new vocab word we're going to talk about. Not too difficult. It's just important that you got to know what it means. Those kind of questions, there'll be questions on the test and quizzes that ask about multiplicity. They're very easy to answer, but if you don't know what they are, you'll get them wrong every time. So multiplicity of zeros in factored form. So first off, I gave you some really easily factored polynomials here. So first off, when we're factoring these, so just like before, look for what they're all divisible by. Okay, so right now they all have an x in them, so I could take an x out. So if I took an x out of this, that'd be x squared instead of x cubed. And notice x times x squared is x cubed. Minus 2x, again, x times negative 2x is negative 2x squared, so I know I'm on the right track. And then minus 15, because x times 15 is 15x with a minus there. So I took that out. Now, let's keep going. Let's keep factoring here. Okay, what could go in here? So what two numbers multiply give you negative 15, and then add to give you a negative 2. So in this guy, I'd say negative 7. I'm sorry, not negative 7. Now I'm blanking. 3. Yeah, negative 5 and positive 3. Yikes. Hard to think. So negative 5 times 3 is negative 15. Add me negative 2. So this is the factored form of it. Off to the right here, I've got the graph of the exact same function. Okay, so notice. I'll look for some correlations here. Where does this cross the x-axis? Here at negative 3, here at 0, and here at 5. How do those numbers correlate with these numbers? Well, because I said factor it, factored form, so there's my answer. But if I said solve, if I said look for the zeros, that means set this equal to 0. So say 0 equals x times x minus 5 times x plus 3, and I asked you to solve for the zeros, what would 0 equal? Well, if I'm multiplying three things together and getting 0, one of them has to be 0, one of the three things. What would I plug in for x to make this term 0? Well, that's 0. What would I plug in to make this equal 0? 5. What would I plug in to make that equal 0? Negative 3. Look over here, negative 3, 0, 5. Okay, so there's a correlation there, some very strong correlation there. Okay, let's go to the next one. What do these have in common? What do they share? What can I divide out of all of those? Okay, and hopefully you're thinking they all have an x squared in them. So if I took an x squared out, well, what times x squared is x to the fourth? X squared. Minus 2, and then what times 2, or I should say x squared times negative 2 what equals negative 2x cubed? That'd be an x. And then this would be a negative 8. Note if I distribute that back out, I've got this answer above. Now what does this factor into? So I've got x squared, x and x, two things that multiply to give me negative 8, add to give me negative 2. So that'd be a negative 4 and a positive 2. Okay, now that's factored form, that's my answer. But if I said solve for the zeros on this. So if I said 0 equals x squared, x minus 4, x plus 2, then we would say that x equals, well, what would I plug in here? So what squared equals 0? 0. What minus 4 equals 0? 4. And what plus 2 equals 0? Negative 2. Let's go over here and look at the graph. Okay, the graph here, notice, here's a negative 2, here's a 0, and here's a 4. Something different happened here, though. On all of these, the graph went through the 0, through the 0, through the 0. Here at negative 2, it went through the 0. But here, instead of going through that 0, it touched and turned back around. Well, what was different? Look here at 0, it came from an x squared, which means technically 0 is an answer twice. So technically, it's 0, 0 for negative 2, and if it has a multiplicity, we call, if it's a factor twice, it has a multiplicity of 2, and it means it'll touch at that point and turn back around, so it bounces when it gets there. instead of going through, it bounces and turns back around. Before, this was a solution 1, so it went through. Okay? So let's see if that holds up. Okay, so this one had a multiplicity. Sometimes we just put mult for multiplicity of 2. These had multiplicities of 1, so they're fine. Down here, let's factor this guy. They all have an x in them, so take an x out. Okay, now factor. So plus 2 plus 2. And look here, this is actually a factor twice. Okay, this is a factor twice. So if I said solve for the x's, so if I said 0 equals 2, you'd say, well, x, when x equals 0, or negative 2, but it's there twice. So I'm just going to write it once. But technically, it was a solution twice, so it has a multiplicity of 2, because it was a solution twice. Well, look what happens over here at negative 2. The graph comes up, and instead of going through it, it touches and turns back around, and then it goes through 0, because that was a solution once. Okay? So down here, multiplicity, sum it all up here. A 0 has a multiplicity of n when it appears as a 0 n number of times. Negative 2 showed up twice, here and here. Up here, 0 actually showed up twice because it was x squared, x times x, so 0 times 0. If the number of times it shows up is odd, the graph goes, and in this case, if it's odd, it goes through the x-axis. If n is even, so if it's a solution an even number of times, the graph bounces or touches and turns the x-axis. So it touches, it bounces against the x-axis and goes back the other direction at 0. So that's important to remember when we're graphing. Okay, so if it is a solution an odd number of times, so in other words, this x was a solution once, but if it was an x cubed, if it was a solution 3 times, it'd just go through it again. It'd be the same, basically the same sketch. Now these might be higher or lower dips, but it'll have the same zeros. Okay, so let's go to the back side. We're going to talk about the factors now. So there's a strong correlation between factors and zeros. So there's a factor theorem. Pretty easy. It's pretty simple to remember. This factor theorem says the expression x minus a is a factor if and only if the 0 of a, or the value of a, is a 0. So if a is a 0, we can write x minus a as a factor. So if negative 2 is a 0, I can have x minus negative 2 as a factor. So when they tell us the zeros, we can actually find what the original equation was. I've got this graph that goes through these 3 points, or it goes through the x-axis at these 3 points. These are the zeros. Okay, so write a cubic polynomial function in standard form with these zeros. Well, if negative 2 is a 0, that means x minus negative 2 is a factor. So I can write in parentheses. Now eventually I'm just going to put plus. If 2 is a 0, then x minus 2 is a factor. If 3 is a 0, then x minus 3 is a factor. Okay, so this is the factored form they want in standard form. So this kind of stinks. So let's multiply it out. Pick any you want here. I'm just going to make this one big plus sign. So I could, in fact, I might multiply these two first and keep this one out front. It really doesn't matter what order you do it. That's just the one I'm going to pick. Actually, you know what? I'll do these two first because I see stuff's going to cancel out here. If I multiply these two first, so I'm going to do first, so that's x squared minus 2x plus 2x is gone, and then minus 4. Now multiply these out. So x squared times x is x cubed, minus 3x squared, minus 4x, plus 12. So that would be, and that's actually one of the cubic functions, because I could actually multiply all these by 2, and it'd still go through the same zeros. Or I can multiply them all by 5. It's just the graph's going to be taller hills and valleys, but it still goes through the zeros. So we'll just always go with the basic one. We don't have to worry about all those other ones that you could use. So we'll start with these basic ones. Okay, number 5. What is the cubic polynomial function in standard form pictured to the right? So it's really the same question, but instead of them giving you the zeros, they want you to look for the zeros here. So I got a 0 right there, a 0 right there, and a 0 right there. Now, the multiplicity on these must all be 1 because they all go through. Now, it could also be 3, but they said that my final function is a cubic, and I have 3 zeros, so they're all 1s, because x times x times x is x cubed. If one of these is an x cubed, it'd be x cubed times x, would be x to the 5th. It would not be a cubic then. Okay, so we wouldn't be able to do that. It'd be a quintic. So we all know these are the first power, so let's just look at these. So this is -1, 0, and 2, so that means x plus 1, because x minus -1. Now x minus 0 is just x, so I'm going to put that out front. And then 2 would be x minus 2 would be the factor. So let's multiply these together. I'm going to multiply these two together first. So x times x is x squared. That'd be minus 2x plus x minus 2. And then I'm going to multiply an x by those. So x times x squared is x cubed. If I add these two together first, that'd be a negative x times x is negative x squared, and then minus 2x. So there's my polynomial function, my cubic function. I should put a y equals on these guys. Okay. The next one, now we're trying to look at multiplicity here. Multiplicity. So I gave you 4 graphs. You just got to pick the right one. Which one of these is right? So I should have so if this is a factor, that means my zeros are -3, -1, and 4. These are to the first power, so these are going to go through. Let's put through for this one and this one. But at 4, it's a squared, so it's going to bounce. So where do I have a through, and a bounce? So in 1, 2, 3, that's not even the right zeros, right? That's not the right one. So it's not a 1, 2, 3, a through, -1, through, and then a bounce at 4. That's the one. That's the one I want. Letter B is the winner. If I just want to keep going here, actually, let's stop for a second on that. I just tricked myself. So this is a -1, 2, 3, through, bounce. So that's another one that could be the winner. Over here, I've got -1, 2, 3, and -1, nothing's going on, so I throw those out. Now, which one of these would it be? Okay, so which one of these would it be? And the reason why I tricked myself is because these two, one is a negative, one is a positive. If you kind of remember when we did quadratics, if it was a positive x squared, it'd be open up. And if it was a negative x squared, it was an open down. Sort of the same thing here. We're going to talk about this a lot more tomorrow on day 3. We're going to talk about all these shapes that could happen. But it's kind of the same idea. It's going to be going up and up if it's a positive, down and down if it's a negative. Now if I multiply all this together, I'd have, like if I multiplied this, I'd have x squared, and then an x and another x. They're all positives. Sorry, it's off the screen there. X squared, x and x. It's all positive. So I have an x to the 4th, which is a positive. So it's going to be going up in both directions. That's actually this graph right here. So this is the winner. That one's not. This would be the graph right here of negative x plus 3 times x plus 1 times x minus 4 squared. Okay, so we'll go over in great detail tomorrow of sorting that out a little better, but just some practice with the bounces and that kind of stuff.